Welcome to the solar system's inner planets, the place you already live. Unless you're an alien, in which case, please don't eat us, we're too high in cholesterol anyway. The inner planets are all smallish and rocky, but they're extremely different from one another. Let's start with the one closest to the sun and work out from there. Planet Mercury, the smallest planet in our solar system. Suck it, Pluto. Has a surface gravity 38% as strong as Earth, double the moon, and similar to Mars. Low enough that I might be able to do a backflip. Sure, plenty of people can backflip on Earth already, but not me. How can Mercury and Mars have similar surface gravity when Mercury is half the mass? Think of Mercury like a bronze statue of Bruce Lee and Mars like, me. I'm bigger and heavier, but Bruce over here works out and can pull a lot harder relative to his size. This works because Mercury is denser and smaller, so standing on the surface you're actually closer to a denser center of gravity, making up for Mercury's smaller mass. The planet Mercury is barely larger than Earth's moon, and smaller than Jupiter's moon Ganymede. If we were to swap Mercury and the moon around, less observant people may not even notice. Mercury is much denser, however, and has far stronger gravity, so high tide at the beach is going to get really interesting. One day on Mercury doesn't make any sense. It spins on its axis 3 times for every 2 orbits of the sun, so one revolution is only 59 Earth days, but a person standing on the surface would see a day-night cycle lasting 176 Earth days, or 2 full Mercury years. That's gonna cause some insomnia. A similar difference between the revolution and a day occurs on Earth too, but it's only a few minutes. One day on Mercury can actually have multiple sunrises. Mercury's orbit around the sun is so uneven, and mixed with its weird 3:2 spin-to-orbit ratio, you can stand in a certain spot on Mercury and watch the sun rise a little bit, set back down, then rise again, go across the sky, set, then rise up a little, then set again, all without taking any drugs. And you would see this even if the radiation from the sun wasn't scrambling your brain. The orbit of Mercury doesn't follow Newton's laws of gravity. This discrepancy led some to believe another planet existed even closer to the sun, screwing with Mercury's orbit. The fictional planet was named Vulcan by the French astronomer Urbain Le Verrier, who put the cart way ahead of the horse in naming something that didn't actually exist. It's not that Mercury is a meandering drunk or anything. It wasn't until Einstein figured out that the massive sun actually bends time itself that we figured out why the orbit is so goofy. Despite being so close to the sun, Mercury isn't all that hot. Well, the equator facing the sun is a toasty 800 Fahrenheit and will definitely cook you to death. The same spot drops to negative 290 Fahrenheit during the night. Some deep polar craters are thought to also contain permanent water ice. Venus is actually hotter. This is because Mercury doesn't actually have an atmosphere to hold in any heat. What small amount of air it does have is created by the burning hot sun lasering atoms off the surface of the planet. Mercury's weak gravity just can't hang on to air like Venus or Earth, so bring your own oxygen. Also some SPF 5 million sunblock. Next up, Venus. Get your acid-proof clothing ready. Venus, planet Earth's twin, and like all sets of twins, one of them is always evil. On Venus, the ground is hot enough to melt your feet. The sulfuric acid rain will dissolve your face. The air temperature will fry whatever's left, and the atmospheric pressure will crush you as if you were trying to scuba dive to the Titanic. Other than that, yeah, just like Earth. Unlike the other rocky planets, Venus spins backwards, opposite from the direction Venus orbits the sun. Don't expect to see a sunrise in the west, however, because the cloud cover is so thick and reflective that despite being so close, the sun will be difficult to spot, assuming the planet hasn't burned your eyes away, which it totally would. In addition to spinning backwards, Venus also spins very slowly. One revolution takes 243 Earth days, or roughly 243 Earth days longer than any lander has lasted on the surface of Venus. The surface is nearly 900 degrees. Hot enough to melt tin, lead, zinc, and overall ruin your day. But don't expect the month-long nights to get any relief. The thick atmosphere traps in all the heat and circulates around the planet quickly enough to keep the entire surface at this insane temperature. The dense atmosphere guarantees that anything but the largest asteroids on a collision course will burn up long before they reach the ground. This means the surface of Venus is oddly devoid of any small or medium-sized craters, like those seen all over Mercury or Earth's moon. It's got plenty of huge ones, however, the kind that definitely would have killed any dinosaurs tough enough to survive on Venus. So, why would anyone want to go to Venus, given that it clearly wants everyone to be very dead? For starters, Venus is often the brightest thing in the night sky other than the moon. Visible only around sunrise and sunset, its shocking brightness causes some to mistake it for a UFO. You know what they say, anything can be a UFO if you're bad enough at identifying stuff. Part of this brightness is because Venus is very close to planet Earth and its atmosphere is very reflective. The dense clouds reflect about 75% of the light hitting the atmosphere. This is similar to those nice puffy clouds on Earth or fresh snow cover, but even brighter because the sun is much closer to Venus, and you know humans, they want to go to anything bright and sparkly, even planets that want to melt everything. But not everything about Venus is quite quite so deadly. Getting there from Earth is easier and faster than going to Mars, meaning communications and resupply can happen more quickly on average, and launch windows occur more often. A year and a half between supply runs isn't exactly Amazon Prime speed, so try not to forget anything when you go. The surface of Venus might be totally inhospitable, but the thick atmosphere opens up a possibility for awesome sci-fi floating cities. About 30 miles up, the atmosphere is roughly the same pressure as Earth, with temperatures between freezing and about 120 Fahrenheit. That's quite a range, so pack for 4 seasons obviously. The 10% lower gravity would mean you walk a bit springier than you're used to, but it's far more like Earth than anywhere else. Oh, except for all the sulfuric acid, don't forget that part. Floating a city on Venus would be easier than on Earth. The atmosphere is mainly CO2, which is considerably denser than Earth's atmosphere. A balloon full of Earth air would float just fine. No helium needed. This means the lifting gas could be the same as your breathing gas. You could live inside the blimp without suffering from jokes about your goofy high-pitched balloon voice. Now that sounds fun and all, but you won't catch me on the next flight there. I say send the robots first. Next up, Earth, the only place in the system where you can get a decent sandwich. Planet Earth, the place you probably live, is really weird. Earth is the only rocky body in the entire system with a primarily liquid surface, and the only known place to find liquid surface water. Mars once had oceans and rivers, but nobody's gonna bring a surfboard with them to Mars anytime soon. Saturn's moon Titan also has surface lakes, but they're made of methane, and it's so cold there the water forms all the rocks. While many planets and moons have atmospheres, the Earth is the only place we know of in the universe to have a significant amount of free oxygen. This is nice because we need it to live, but it also means finding lots of free oxygen in the atmosphere anywhere else could point to the existence of life making that oxygen. You know, alien trees or algae, for example. Some new telescopes like James Webb can detect what's in the atmosphere of other planets that cross in front of their stars, but despite thousands of known exoplanets, none are known to have free oxygen in the air. Speaking of life, Earth is the sole known harbor of unintelligent life in the universe. Also, some psychotic apes who keep launching random stuff into space for some reason. The search for intelligent life continues, but I remain hopeful we'll find it someday. Perhaps one of those robots on Mars will achieve sentience, who knows? Earth, the only place you have ever been, probably, orbits in the solar system's habitable zone, but it isn't the only planet to do so. Possibly Venus, but definitely Mars is the right distance from the sun to have surface liquid water, but it doesn't. This range is certainly not a for sure kind of thing, but you wouldn't expect Mercury or Pluto to have surface oceans. Just because Earth is habitable doesn't mean it's safe exactly. Mars may not have breathable air, but it also doesn't have malaria or tigers or sharks. You won't be able to breathe without a spacesuit, but you also won't have to watch your back for anything that wants to eat you. I mean, probably not anyway. Never say never. Earth is the densest planet in the whole system. Its rock and metal composition might seem to contain less dense stuff in proportion than Mercury, but the larger size and higher gravity crushes all of that stuff together much tighter than any other planet or moon. It's denser than the other rocky planets, the moons, the gas giants, and even the sun. The Earth has maintained its atmosphere in part because the Earth has the strongest magnetic field of any rocky planet in the solar system. Mars once had more air, but the solar wind and radiation slowly blasted it off into space. What remains on Mars, like the thick atmosphere of Venus, is made almost entirely of much denser CO2, which can be held much more easily by the planet's gravity. Earth would suffer a similar fate if we didn't have such a strong magnetic field. We also wouldn't have those cool northern lights, answering the question what it would be like if the sky started having a rave party. The Earth spins faster than any other rocky planet, and it used to be even faster. Mercury and Venus have days we would measure in months, but Mars comes closest at 24.5 hours per day, so go there if you like sleeping in. The Earth is slowing down over time, however, because of the gravitational interactions with its gigantic moon. The Earth is the only planet in the solar system with a moon a quarter of its own diameter. To put that in perspective, if Jupiter had a moon with a similar size relationship, it would be like 4 or 5 times bigger than Earth. This in part leads some scientists, like Dr. Alan Stern, to call the moon a planetary mass moon, making Earth nearly a binary planet. Pluto and Charon are similar in their relationship, but we don't talk about Pluto around the other planets. Now let's leave the place where I keep all my stuff and head to the moon, the only other place we know of you can find human footprints. Earth's moon is actually very strange. Despite Earth not being very giant, our moon is the 5th largest in the solar system. It's even bigger than all the dwarf planets. Suck it again, Pluto. The moon doesn't glow, obviously, but reflects light from the sun. If it produced its own light, the side facing away from the sun would glow too, but it doesn't. The bright light of the night and bringer of werewolves isn't as bright as you think. Despite how bright it appears at night, the moon is actually pretty terrible at reflecting light. Light reflection is measured in something called albedo. Fresh snow has an albedo around 0.9, reflecting 90% of the light that hits it, while black charcoal is at 0.04, reflecting just 4% of the light. The moon, despite looking a bright grayish white, is around 0.14 4, reflecting barely more light than asphalt. It only looks bright because it's reflecting 14% of the light from the sun. Where did the moon come from anyway? Moons form from a variety of different ways. Some are likely to form from the same dust clouds that form the planets. Others are captured asteroids, and some, like our moon, come from massive collisions in the early days of the solar system, when things looked less like a serene space ballet and more like a demolition derby. Recently, computer simulations by NASA's Ames Research Center and Durham University have demonstrated that a collision between the early Earth and a Mars-sized planet could have formed the moon very quickly out of debris. I personally wouldn't want to be there when this happened, but it shows that during these kinds of impacts, planets are much less rocky and much more liquidy than we would think. The Earth still has a super thin, hard crust over a syrupy liquid magma mantle, but the moon is also thought to have a creamy, semi-liquid center around an iron core, though much cooler and much deeper than on Earth. The volcanoes may have stopped erupting long ago, but you can still see some of the lava fields if you look at the moon. They're the darker areas. If the moon was truly formed out of a bunch of Earth blasted into orbit, you would expect the rocks to have a composition similar to Earth, and that's exactly what the Apollo astronauts discovered. All that effort to go to the moon and they just got Earth rocks. Well, kinda. They are a bit different. On the moon, there's no atmosphere and no oceans or any other process to erode stuff. On Earth and Mars, the dust gets blown around, which tends to round off all the broken sharp edges. But on the moon, the rock, sand, and dust particles stay jaggedy razor sharp. This dust is electrically charged and static clings to everything. If a spacesuit, or anything else for that matter, gets covered in the stuff, every movement will make the dust cut into everything it touches, like a billion microscopic power sanders. This is bad news for anything that needs to last a while on the moon. They've been working on this dust problem since the 70s, but I'd still recommend you hold your breath if you go there. The problem is so bad that every sample of moon dust on Earth has damaged the seals used to keep them moon fresh, allowing in all the filthy Earth air and contaminating them. If that's not bad enough, moon dust is also toxic to humans. In lab tests, exposure tended to kill cells, which doesn't bode well for life on the moon. Apollo astronauts suffered from itchy eyes, respiratory problems, and general hay fever type symptoms when they brought some dust into their lander on accident. Only 12 American guys have visited the moon, and only briefly, so we don't have a great sample of what lunar life will do to humans over time. But in typical American camping in the wilderness fashion, we did leave garbage scattered everywhere. If you look close enough, you might find beer cans behind a boulder somewhere. Typical tourist. Show up, play golf, take some rocks as souvenirs, and go home. But unlike your last trip to Hawaii, when you arrive on the moon, you will quickly lose tons of weight. With 16.5% the gravity of Earth, a 200-pound guy from Earth will only weigh 33 pounds on the moon. I still think a gym membership would be cheaper though. The moon spins at the same rate it orbits. This is called tidal locking and is actually pretty common. Many moons around other planets are tidally locked. Pluto and Charon are locked to each other. And if you could play things forward 50 billion years or so, the Earth would eventually be tidally locked to the moon, because orbital mechanics is evil and wants to torture anybody who dares to try and understand how it works. To make it even more confusing, have you ever noticed we have a lunar calendar, lunar landers, lunar regolith, lunar this and that, not mooner calendars, landers, and so on? Language is a funny, changing thing, but in general, a moon is something that orbits around something else, like a planet or an asteroid. But Earth's moon has a different name, Luna. It's not a big problem because Earth only has one moon, but there is no the moon when you're on Mars, since that has two of the things. The problem gets even worse on the gas planets. Speaking of Mars, let's go there next and explore the dusty red planet and eventual kingdom of Elon Musk. Mars, the fourth planet from the sun. A red world inhabited by robots. This may be a future outpost for humanity, the next giant leap for mankind. But I get the feeling it hates everything from Earth and it's going to fight humanity every step of the way. Not a surprise for a planet named after the Roman god of war. Humans have studied Mars for millennia, noticing it as a bright blood-red star that changes its location against the background. Ancient Greeks called it, and others like Jupiter, Saturn, and Venus, wandering stars. Only in unpronounceable Greek, where we get the name planets. But why is it red? Fittingly, it's red because of all the iron oxide, similar to the chemical that makes our blood red. And Mars is likely to claim more than a little human blood during any attempted colonization. Astronomers studying Mars took advantage of ever-improving telescope technology, first figuring out the details of its orbit, then mapping out its surface. Kinda. In 1877, Italian astronomer Giovanni Schiaparelli drew maps showing lines on the surface. These weren't real, but a result of an optical illusion, probably because he was using a telescope from 1877, and crazy drugs were available over the counter at that time. I'm not saying there's a connection, just draw your own conclusions. And the Italians loved their wine. He called these grooves canali, because that's the Italian word for that, but it was later mistranslated into English as canals. You know, like those things that have to be dug by humans. Leave it to English speakers to not understand foreign languages. This led many, like Percival Lowell, who had a much larger telescope, to assume a technological society lived on Mars. He even wrote several popular books on Martian life, which all ended up being wrong. Remember, just because it's in a book doesn't make it true. As telescopes got better, the canals slowly disappeared. Intelligent Martians were never found, but that didn't stop a bunch of books and movies from being made, always showing Martians as evil invaders. But who's invading who now? We started sending satellites and landers to Mars about as soon as we possibly could, with mixed success. The Soviets, for all their success landing on the nightmare-inducing Venus, were never able to succeed at Mars. But what did NASA discover? Mars is a planet of contradictions. Clear evidence of rivers, oceans, and lots of atmosphere in the past, but now it's a dry, dusty ball with hardly any air. The solar system's largest volcano, but no sign of any activity. The solar system's largest canyon, many times more grand than anything on Earth, but no river flowing through it. All signs pointed to Mars being a wet, warm planet, capable of supporting canal-digging Martians at one time in the distant past. So what happened? Mars does not have a strong magnetic field. With nothing to protect the atmosphere and hardly enough gravity to hold onto it, solar winds can literally blast air molecules away from the planet, like a comet losing its water. What was once an atmosphere thick enough to maintain oceans is now just 1% the pressure of Earth. Enough to burn up your spaceship when you try to land, but not enough to slow it down before slamming into the surface. Enough, as it turns out, to fly an insanely expensive electric drone, but that's about all. The air pressure is so thin, in fact, that hurricane-speed winds wouldn't be able to blow you over. Now I know what you're thinking. Without the magnetic field, the sun's radiation will cook you, just like the atmosphere, right? Well, yes, it totally would, but not as bad as you think. It depends where you are on the surface, but the radiation in some areas is only high enough to increase your cancer risk as bad as about a pack of cigarettes a day. That's pretty bad, sure, but that assumes you're just standing there on the surface. If you're in a building with some dirt piled up around it, that drops significantly. Caves are even better. Humans may develop spaceflight only to end up as cavemen again, so why would we want to go there? There may still be microbial life. NASA has detected super salty water under the surface, and at least on Earth, everywhere you find water, you find life. Discovering that would be pretty cool, and a guaranteed Nobel Prize, so there's that. Mars has 38% Earth's gravity, enough to give you a nice spring in your step, and potentially high enough to prevent or reduce the bone density loss seen in astronauts on the space station. Mars also has a 24.5-hour day. Who wouldn't want to hit that snooze button a few more times and get away with it? Temperatures on Mars are pretty cold, like inland Antarctica cold, but in the right spot, a hot, blistering summer day might get to 95 Fahrenheit. And then there's the dust. The planet is covered in the stuff. It slowly builds up on solar panels and chokes out the power, most recently killing NASA's InSight lander. This stuff gets blown all over, and occasionally blocks out the sun around the entire planet. Unlike moon dust, Martian dust isn't razor sharp, so that's nice, but it's definitely still poisonous. It's packed with perchlorates, which are toxic, but it's possible to wash them from the soil with an ample supply of clean water. Oh wait, the oceans are gone. Whoops. Without flushing that out, Matt Damon would have a lot of trouble growing his potatoes there, even with a bunch of astronaut poop. Still, exploring and colonizing Mars could give us access to the asteroid belt and eventually the outer planets. I say let's do it. You first though. I'll wait till you have a coffee shop set up. If you want more about the inner planets, click right here to find out why Earth's moon is slowly drifting away. You don't need to worry though. I mean, maybe you should. Depends how long you want to live.